lopsided. So we have to make sure that we eliminate all possible bias, all bias from this. We certainly don't want to ask one specific group, like all the football players or all the track players. They'll be out there too, running track out there. We maybe want to ask the baseball players, did they say yes? Oh, their baseball field is over there. They don't care about those bleachers there. So you got to be careful who you ask. You want the most unbiased group, the most randomized group. Now, when we collect your data, we're going to use this data to make a decision, to make an inference, to come up with something valid. So we want to identify all your variables. Try to keep as little variables as possible so you can keep control of this. And where is your population? Well, in our scenario, our population is our school. That's the population. And we have well over 3,000 students in our school. So that's a large population. You want to develop your plan for collecting your data. We were talking about this. How should we do this? We want our sample to be a good representation of our population. We're going to depend on what they say. They have a big say in this. We're going to collect our data. We have to decide. Do we just ask them as they walk in? Would you be in favor of bleachers for the football field? Yes or no? Do we give them a little ballot that they say, yes or no? Maybe they feel awkward. They're standing in between two football players, and we ask this little girl here, standing here between the two football players, would you be in favor of bleachers? And she wants to say no, but there's two big guys standing around her, so she says, yeah. She's a little nervous. So do we give them a seal thing that they just check off yes or no and then stick in a box? These are things we need to think about. We describe our results and we interpret them, and we use this as a basis for making our inference about this. We found that most of the kids feel that they would like to see bleachers around our football field. We had a majority of all our randomized people say, yeah, put those bleachers out there. We already did the football field. We might as well do the rest of it. Or we could say, well, the majority said, no, they really would rather work on other fields in this school. Maybe get the black box back. We lost our black box. Maybe get that back. I will tell you one thing about the black box.
Oh, no.
Okay, so these are things that we check for as we go. All right, data collection. You have 4 ways to collect your data. Actually, a couple of them will overlap. You can do an observational study. An observational says just that. You observe. You observe, you don't influence, you just observe, and record your information. Say I want to know how long it takes 5-year-olds to put together a puzzle. So I go into the kindergarten rooms at random. I choose different schools, different random 5-year-old classrooms, and I watch them put together puzzles. And I write down how long it takes the average child to put together a puzzle. I don't suggest that they put all the same colors together or they put all the corners together. I just observe, observational. Okay? Perform an experiment. This one's very much like what you do in science. You make a hypothesis. You set up your control variables. Maybe I want to see at what temperature my water evaporates and the saturation dissolves into what maybe calcifies or whatever makes my little residue. I want to know at what temperature will this happen. I only want to vary my temperature. I don't want to vary the types of water I use or the types of solution. I want those to stay steady. I repeat my experiment many times so that I can test this. We do the same thing in statistics. We set up an experiment, we repeat it as necessary, and we try to control what our variable is. Too many variables will have an effect on what we do. Now, in an experiment, you generally have 2 groups. You have a control group and you have a treatment group. Your control group says, okay, say I have this high energy drink, and I'm marketing this high energy drink. So I'm going to take a population of all people that go to the gym, because I want to see their improvements because I know they already go to the gym. And I look for people that go to the gym on the same basis. They go 3 or 4 times a week. They do the same type of activities, and whatnot. I separate them into 2 groups, a control group and a treatment group. And every time before their workout, I give them my high energy drink, my treatment group. My control group, I give them a drink, but it just contains like colored water in there. They think they're getting a high energy drink. They're just getting water that's been colored purple to make it look like they're getting some special drink. But sometimes we have a placebo effect. The group that doesn't get anything automatically gets this new surge of energy because they think they're getting it. They don't know that they're not. We can't tell them. It's called a blind experiment. You don't tell the people what you're giving because it has a psychological effect on them. So after the course of time, I measure. Is my treatment group actually performing better than my control group? Did this energy drink really make a difference? I measure their heart rates, their endurance, how long they work out, maybe how much weight they're pumping or pushing or whatever. And I do things like that. But I need to keep a control group so that I can see what the changes are. And I need to make them as similar as possible. If I pick a group that's automatically a good workout group, and then I pick one that's not, I'm not going to be able to compare my results. So that's an experiment. The same as you do in science. You change one variable at a time. Okay? Simulation. A simulation has an effect that sometimes I want to separate my groups and I want to give them something, but it's dangerous. Maybe I want to give them the highest level of iron that I possibly can to see if it shuts down their organs. Okay? I certainly don't want to be able to give that to a person, right?
Oh my God.
But I want to say, what is the highest level of iron that you can take in your system without having a problem? I need to know that. That's good as a scientist. That's good to know. I want to make sure that everybody stays below those levels. But I can't, so I can't. So I do a simulation. A simulation works on a machine, a computer. Many things are simulated by your computers. The effect of an organ, every time I add a little bit more iron. You see simulators in airplanes, people that are taking flying lessons. Your games, your video games are simulators. You're not really killing people when you play that war thing, whatever that is. Call of Duty. You're not really killing people. You're simulating this, right? The very first video games, what I remember my kids having, they're driving along a road and all of a sudden they zoom off the road here and they get back on. Does that happen in real life? No. It's like a simulation. So simulators are used when it's too dangerous to perform an experiment. And lastly, we have surveys. We send out a survey. We want to know who's going to vote in the next election. Take an active part in your community. Who's going to be voting? We want to know how many voters we're going to have to represent our district. So we send out a survey. Now, if I just want to know all of Newburgh, I can send out a survey to every person in Newburgh, town and city. That's called a census when it goes out to the whole population. If I find that that's way too much for me to control, it's going to be too costly for me to send out all these surveys, I'm probably not going to get them back in a good time frame, I may do some sampling, just like we did with the kids voting for the bleachers. I'll sample. So we have a census and a sample. Again, we want to make sure that all our sampling is a good representation of our population. These are our 4 methods that we use to collect data. So let's take a look at an example. Decide whether this is an experiment or an observational study. Researchers study the effect of vitamin D supplementation among patients with antibody deficiencies or frequent respiratory tract infections. To perform the study, 700 patients received this amount of vitamin D3 for a year, and another 70 receive a placebo.
It's an experiment because you have a control and variable.
Good. You have a control group. I give it to this, my treatment group, I give it to this group, and then this group receives a placebo. Is this dangerous? giving them a supplement, and I research it. Supplements usually just like reset your body if your body doesn't need it. I want to see if it's helpful. Researchers conduct a study to find U.S. public approval rating about the president. To perform the study, researchers called 1,500 U.S. residents and asked them whether they approve or disapprove of the job that the president is doing. Observation, right? Observation. We're just observing. It's a survey. We said survey, and it's a survey. We send out a survey, but since I'm just going to call, I'm just observing. It's a little overlap in your observation and your survey. So I'm just observing what their answer is. I'm not influencing them in any way, means, or form. One more, guys. One more. The Pennsylvania Game Commission conducted a survey to count the number of elk in Pennsylvania. The commission captured and released the elk, which they classified into different categories. Observation. Did we in any way control this? No. Observation. And again, the study is observation. Okay? Tomorrow we'll continue with this.